And tell me the following. What's the sign of 2 pi over 3? Go. Go, 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 go. Go. Put it down. Put it down. Did you say -1? Oh, it's so slow for some of you. What's the sign of pi over 2? What is it? Yeah, good. One. What's the sign of 5 over 3? What's the sign of 0? Sign of 0. Sign of 0. 0. What's the sign of pi? Sign of pi. What's the sign of pi? What's the sign of 1? What's the sign of 2? No. Okay. We're not there yet. We're not there yet. You don't know the sign of 1. You don't know the sign of 2. This would be something that you'd have to plug in a calculator. Now, but you got to understand the value 1. Would you say that 1 is close to pi over 3? Why would I say pi over 3 is close to 1? Because pi is 3.14, and 3.14 divided by 3 is very close to 1. So you know what the sign of 1 is close to. What's the sign of 1 close to? It's close to the sign of pi over 3. It's got to be close to root 3 over 2. Cool? So like, guys, you could find the trig function of any radian measurement, including decimals, including whole numbers, like 1 and like 2. The problem is we've stuck to these pi values. Why? Why have we been just finding the sign of 2 pi over 3 and the sign of pi and the sign of 3 pi over 2 and the sign of... Because they're universal numbers that create 30, 60, 90 triangles, which we know the side lengths of. They create 45, 45, 90 triangles, which we know the side lengths of. I don't know what the triangle is that has a radian measurement of 1. 1 is close to pi over 3, but it's not exactly pi over 3, so it's approximately root 3 over 2. This is very important, and this comes back to your test question. You guys remember the test question? I don't want to blast this, so I'm not going to. The test question where you're like, this is a theta equal to 2. You guys remember that? You guys were all screwed up on that question. You're like, what do you mean 2? Do you mean 2 pi? No, just 2. Go away. Just 2. What is 2 as a radian? Well, it's just some angle. It's not 30, 60, 90. It's going to be close to 120 degrees because 2 pi divided by 3 is close to 2. But 2 pi divided by 3 is going to be a little bit more than 2. So this angle is probably, I don't know, around 110 degrees. I don't know, but that's the degree equivalent. 2 radians is equivalent to like 110 degrees, around there. Cool? Now what you guys are expected to do is find this arc length. Well, it's just like scale it. The theta measurement, the radian measurement of 2 times your new radius. You should have gotten 10 as your answer. Okay? But it's understandable that you guys are confused with that question because you were never asked the sine of 2, but you could have found it. Why am I saying this? Is because we are going to graph trig functions. This is going to be close to root 3 over 2. Now, stop writing and let's just do a little like sidebar. In all of math classes, we've been just investigating one different type of function after another. We started with linear equations. We moved into quadratic equations. You guys remember the first time you graphed, say this? Let's even make it simpler. What did you do the first time you graphed y equals x squared? You didn't just draw a u because you didn't know it looked like a u. How did you know that it looked like a u? How do you graph it? Tell your neighbors. Right. We took x values like 1 and 2 and 3 and -1 and -2 and -3. We plugged it in to the function to get outputs. We got 9, 4, 1, 0, 1, 4, 9. We thought about if we plugged in a decimal, how, yeah, it would connect these points, and we create this shape. We took x values, we plugged them in, we got y values, and we plotted. Trick it. Sit over there. Yeah, I'm not even going to pick on Woods. I'm picking on you today. Go sit over there by yourself. Not doing it on the first lesson of a new year. Cool. We are about to graph y equals the sine of x and y equals cos x. And we are going to attempt to graph it like we would graph anything else. There's one point you do know. 0. We'll go to the notes in a second. What's the sine of 0? Cool. Here's one point on the graph of y equals sine x. Okay? Now, you might think, oh, the graph of sine x has to look like a circle. But no. Understand that the unit circle helps you understand your ratios. Because we're talking about a circle with a radius of 1. It helped us create our triangles. Sine is all about SOHCAHTOA. It's opposite over hypotenuse. The hypotenuse is always 1. But we were like, oh, opposite hypotenuse. The unit circle helped us. But that's not what I'm doing here. I'm not going to say, oh, sine looks like a circle. The circle will help us. Well, the problem is, like, we're used to plugging in whole numbers, like 1, 2, 3, -1, -2, -3 into functions because they've been easy to plug in. All right, what's the sine of 1? Yeah, you don't know. You know what it's close to, but you don't know. Do you know what the sine of 2 is? We don't know. It's close to 2 pi over 3. 2 is close to 2 pi over 3, so we know it's going to be close to. Do you know what the sine of 3 is? You know what it'll be close to, but you don't know what it is. So this is the first thing I got to get through to you guys. The way we graph this function is not the way we graph y equals x squared or any linear function because we can't plug in these whole numbers. But what we're going to do is plug in things that are close to it. Pi over 3 is close to 1. Would you guys agree with me? Okay, so I could plug in pi over 3. I could plug in 2 pi over 3. 2 pi over 3 is close to 2, right? So I'm just kind of changing my inputs. So I'm using values. And again, this is just a number. It's close to 2. It's close to 1. We got something close to 1.5. 3.14 divided by 2 is close to 1.5. These are our inputs. You guys understand that? And you guys comfortable with that? They're decimals. We're not used to liking decimals. But here we love decimals. Because I don't know what the sign of 1 is, but I do know what the sign of pi over 3 is. Cool? All right, let's go to our notes. We're going to start at 0, but I'm going to put 0 right here. So I'm going to put 0 right here. Okay? I'm not giving you a y-axis, but you can draw a y-axis right here if you want to, but I'm not going to label it with any numbers yet. Okay? Again, we would love to plug in whole numbers. We love plugging in whole numbers, but not the trig function, because I don't know what the sign of 1 is. I'm not going to put 1 here. I don't know what the sign of 1 is, but I do know what pi over 3 is. And I know pi over 3 is close to 1. So I'm going to put this tick mark down at pi over 3 and understand that this value is close to the value 1. This is a decimal close to the whole number 1. All right, now you already know what the sign of 0 is. You told me it's 0. What was the sign of pi over 3 again? I forgot to tell your neighbors. What's the sign of pi over 3? Okay, what the heck is the square root of 3 over 2? It's another number. It's another decimal that people get freaked out about, but it's okay. I could type it into a calculator. It's not close to 1. It's closer to... Let's see. Any more guesses? Any more guesses? Who's going to be closest? What's square root of 3 is 2? Give me a close answer. 0.866. Okay? 0.866. If you have 0.866, you win. All right, guys. 0.866. Cool. Now, the next whole number that we're close to, and I'm going to put the 1 right down here because pi over 3 is close to 1. The next whole number that I'm close to, 2, is like 2 pi over 3. Again, I'm just essentially canceling the pi and the 3 because 3.14 is very close to 3. So 2 pi over 3 has got to be close to 2. But I have a value in between these. And I'm going to try to space out these pi over 3s so that it's like 1, 2, 3, 4, 5, 6, essentially. I kind of want to space things out more. But this is 3 pi over 3. This will be 4 pi over 3. This will be 5 pi over 3. And this will be 6 pi over 3. Again, it's close to 3. It's close to 4. It's close to 5. It's close to 6. I'm not going to write that anymore. You guys should understand that, right? You're comfortable with that. We're plugging in decimals because they're values that we know the answers of. We need also some other values that are in between these. Like pi over 2 is in between pi over 3 and 2 pi over 3. It's going to be like 1.5. 3 pi over 2 is in between 4 pi over 3 and 5 pi over 3. You guys would agree with me with those. Okay, so we got like these 3. We got some space. We got pi. We got some space. We got these 3 in a row. We got some space. We got 2 pi. I could probably space out 2 pi a little bit more. Cool. All right. 1.5 pi over 2. What's the sine of pi over 2? I need everybody to do this and not copy it down because it's very important. What is the sine of 2 pi over 3? Hey neighbors, what's the sine of 2 pi over 3? Or figure it out or flip to the back where you already figured it out. What's the sine of 2 pi over 3? You found it at the beginning. Okay. I got 0.866. I got 1. I go back to 0.866. We go to pi. Look on the back if you want to, but you should know how to find it just by thinking about it. What's the sine of pi? Good. Let's keep going. Let's plug in something close to 4. 4 pi over 3 is close to 4. What's the sine of 4 pi over 3? You did it on the back of your paper. What's the sine of 4 pi over 3? Tell your neighbor. Oh, negative root 3 over 2. That's negative 0.866. What's the sine of 3 pi over 2? What's the sine of 5 pi over 3?
Negative root 2 over 2.
No, root 3 over 2. Yes, negative root 3 over 2. What's the sine of 2 pi? Everybody, think about it and then tell your neighbors, what the heck is the sine of 2 pi? 0. Okay, let's look at the y values that we are producing. We are going to put some values on our y-axis, okay? I have 0, okay, y equals 0. I have root 3 over 2, that's 0.866. I have 1. I have 0.866, I have 0, I have negative 0.866, I have negative 1, I have negative 0.866, 0. So notice, I don't go very high with my y values. I only go to 1. I don't go very low with my y values. I only go to negative 1. Okay, let me just put 1 right here. I'm going to leave some space in case we're going to go above it. Let's see what happens. I got 0.866, which is all the way up here. Again, this is the same as root 3 over 2. And then I got negative 1. I'm going to leave some space in case we're going to go below that. And I got negative 0.866. Let's start plotting some points. So, 0, 0. Again, it's an x and a y axis. It's like we're graphing y equals x squared, only we're plugging in the decimals that are easy to plug into. Pi over 3, 0.866, root 3 over 2. Pi over 2, 1. 2 pi over 3, 0.866. Pi, 0. 4 pi over 3, negative 0.866. 3 pi over 2, negative 1. 5 pi over 3, negative 0.866. 2 pi, 0. We'll pause there. Cool. Does it stop at 2 pi? Is that the last value that I can find the sine of? Does it stop at 0? Is that the last input or the first input? Question? You got it? Could you plug in things bigger than 2 pi? Give me an example of something you can plug in that's bigger than 2 pi. Tell your neighbors. It's 2 pi. Good. We understand that we can go around our circle. Let's see, orientation. We can go around our circle. We get to 2 pi. 2 pi is coterminal to 0. We are back to our original angle. But we can keep going. We talked about Tony Hawk, Mr. 5 pi. You can keep going. You could plug in 7 pi over 3. Why don't we just skip the pi over 3 and just go to the pi over 2? What is 1 pi over 2 more than 2 pi? What's that? Write that down. What's 1 pi over 2 more than 2 pi? Tell your neighbors, what's a pi over 2 more than 2 pi? You got to do this in your lesson today. 4 pi over 2 plus pi over 2 is 5 pi over 2. What is the sign of 5 pi over 2? What's the sign of 5 pi over 2? Let's do another pi over 2. 6 pi over 2. What is the sign of 6 pi over 2? What's the sign of 3 pi? 0. 7 pi over 2. What's the sign of 7 pi over 2? What's the sign of 8 pi over 2? What's the sign of 4 pi? What do you notice? It repeats. It's going to repeat. Obviously, it's going to repeat. If I put any of the pi over 3s in between these values, or any of the values, we know they're going to be coterminal with the pi over 3s that I've already listed. So we know that as we continue to add with our x's, our y's don't go up. Our y's aren't going to increase. They're not going to decrease. They're going to repeat. The sign values, the ratios, are limited to angles that we looked at in our unit circle, where the maximum value is 1, the minimum value is -1. The middle ends up being 0, and we just repeat over and over and over. Down, up, down, down, up. You know, up, down, up, down, up, and we can keep going forever and ever. Okay, 0, the last one we could have plugged in. Could we plug in negative x's? Now, I can't plug in -1. I don't know what the sign of -1 is, but I know what the sign of negative pi over 3 is, right? I know what the sign of negative pi over 2 is, right? Negative pi over 2 is like -1.5, so we're close to -1.5. So keep going. What if we went to the left? What would you get? Again, negative pi over 2, coterminal with 3 pi over 2, we're going to get a -1. Negative pi, coterminal to pi, 0. Negative 3 pi over 2, coterminal to pi over 2, we're going to get 1. And we get the repetition of this wave graph. Plug in bigger x's. You're not going to get bigger y's. You are going to get repeated y's because of your understanding of what it means to be coterminal. Ready? Set. Y equals sine x. We plug in bigger and bigger x's. What were the x's we plugged in? Something close to 1. What was that? What was our radian measurement that's close to 1 that we know? Pi over 3. What was the sign of pi over 3? Which was equivalent to what decimal? I'm going to go to 1, and we're going to see it's going to be close to 0.866. After I zoom in a little bit. 1, 0.866, right? Now, if I wanted to, I could say, hey, when x is pi over 3, here is that point, pi over 3, comma, 0.866. Here is the point, pi over 2, comma, 1. It actually helps us. Thank you, Desmos. Desmos does a nice thing. It actually gives us pi's as intersections. Okay? We saw 3 pi over 2, -1. We saw something close to 2 was like 2 pi over 3. Well, 2 pi over 3, 0.866. There's 2 close to 0.866. It repeats. It doesn't grow. It repeats. Doesn't matter how far you go to the right. we're just going to get coterminal angles. Doesn't matter how far you go to the left. We're going to just get coterminal angles to what's important are one period of a graph. This is our one period of a graph. What do I mean by period? It is like the length it takes for my graph to be created, and then it gets repeated. Everybody, please understand that from 0, and I can do it up here, from 0 to 2 pi, we have what's called the period. This is a new word that you haven't used for other graphs, but we're going to use it. This graph has a period. How long it takes till things repeat itself. From 0 to what? 2 pi. Why? Because you go around the circle in 2 pi radians and then you start repeating itself. For the graph of sine x, the period is from 0 to 2 pi. We'll say the period, it takes 2 pi radians to start repeating itself. This graph, since it's so special, it's got other words that we haven't seen before for other graphs that we are going to use. One word called amplitude. The amplitude is like the height that we go up or the height we go down. This would be considered the amplitude. This would also be considered the amplitude. We would call the amplitude for this graph 1. It goes up 1, it goes down 1. Okay, so we have the period of this graph is 2 pi. We have the amplitude, how high it goes up and down, is 1. We have the middle of our graph, okay, where we kind of reset. We're going to call that the midline. Here's the midline. It's at y equals 0. The center of the graph. We go up our amplitude, down our amplitude. Cool? If I were to shift things, I would start my phase at a different number. If I were to shift this left or right, we'd call that a phase shift. Here, I am starting at 0, so I'm going to say my phase shift is 0. Cool? I'm starting at 0 as an x. This is where my start. It takes 2 pi before I start repeating. My amplitude is 1. I go up 1, down 1. Cool. My steps, I say are pi over 2. Why do I say it's pi over 2? I go from the middle to my max, to my middle, to my min, to my middle. Each step along the way is a pi over 2. I kind of split my period into 4 parts. And like my steps to my major things, this is a word that I created, the steps, pi over 2. Cool. The period of the sine graph is 2 pi. How long it takes for our graph to start repeating itself. Okay? What does cosine look like? Okay, well, let's start with 0. Excuse me. What's the cosine of 0? Nailed it. Now, I'm going to show you something. I hope it makes sense to you. I love looking at it. Here is last unit. We use the circle, the unit circle, to understand our ratios. We understood that the sine value was our y distance divided by our hypotenuse of 1. So we just have to worry about our y distance. Cool? That's last unit. We are doing this in this unit where understanding our unit circle, understanding how the sine values are created, we plot these heights. The y coordinates are the y values. Now, really quickly, you see sine starts at 0 because the vertical distance is 0. It gets a maximum of 1, but it's got all of these angles in between. The y distance is still positive. It gets to 0. The y distance is now negative and increasing till it gets to the minimum, -1. And the y distance then decreases till it gets to 0. Beautiful. That's what you just created with a couple dots. It's just using a bunch of dots. Now, what will cosine look like? Cosine is the adjacent side. We already said the cosine of 0 is 1. Well, if the cosine of 0 is 1, and we just pick out the big points, we realize we're going to start at 1. We're going to hit the cosine of pi over 2, which is 0. We'll hit the cosine of pi, which is -1. We'll hit the cosine of 3 pi over 2, which is 0. We hit the cosine of 2 pi, which is 1. Just like sine, just starts at a different spot. And instead of a vertical distance, it's talking about a horizontal distance. So kind of doing this quickly just because we got to get to the good stuff. We know that if we went to say pi over 3, cosine of pi over 3 is 1/2. If we went to pi over 2, cosine of pi over 2 is 0. 2 pi over 3, -1/2. Okay, this is interesting. I'm starting at 1. Pi over 3 is like 1, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. In between pi over 3 and 2 pi over 3 is going to be a pi over 2. In between 4 pi over 3 and 5 pi over 3 is going to be, wait, this is 5 pi over 3. Is 3 pi over 2. This is 6 pi over 3 or 2 pi. Cosine of 0, 1. Cosine of pi over 3, +1/2. Cosine of pi over 2, 0. Cosine of 2 pi over 3, -1/2. Cosine of pi, -1. Whatever comes back. Cosine of 4 pi over 3, -1/2. 3 pi over 2, 0. 5 pi over 3, 1/2. 2 pi, 1. It continues to go to the right and to the left, just like sine does, but it starts at 1. Why? Because the cosine of 0, the adjacent side length is the horizontal displacement. The cosine of 0 is 1. And it goes the same in the other direction. The cosine of -pi over 2 is 0. The cosine of -pi, -1, and it keeps going. Don't want to spend forever creating it, but you got to understand how it's created. Okay? Now, characteristics. It's got an amplitude. Tell your neighbors, what's the amplitude of cosine? Yeah, it's the same as the amplitude of sine. Its maximum length in the unit circle, which is what we use because we have to divide by 1. It's nice to use, is 1. It's either to the right one or to the left one. What else did I talk about? The period. How long does it take for our graph to start repeating? Yeah, same thing, 2 pi, of course. Like, we start to repeat when we go around our entire circle. Where's our midline? Our midline is still going to be at y equals 0. We don't have any phase shifts. We are starting at x equals 0. And every step to get to the next big point is going to be taking that period and dividing it into 4 steps. And maybe I'll just define that. The steps that I take is really my period divided by 4. Cool. If you looked at the graph of cosine, you will see it's the exact same idea as the graph of sine. Only start somewhere else because the cosine of 0 is different than the sine of 0. There it is. Yo, do you guys remember Unit 5? Right before we went on our holiday break, we had this whole unit on transformations. Who could tell me what you could do to our sine graph so that it moves on top of my cosine graph? Now, you might think -1, so let's try to take our sine graph and do -1. Where do I put -1? Here? No, that's a vertical shift, so that's wrong. What do I have to do? Parentheses, -1. Oh, nope, sorry, you got it wrong. That went the wrong way. Oh, let's try +1. Ooh, you're close, but you're not close. Oh, let's think about this. Where is the maximum value of sine? I'm not going to show you. When does sine equal 1? When does sine equal 1? When does sine equal 1? Pi over 2. When does cosine equal 1? Cosine of 0 is 1. The sine of pi over 2 equals 1. Okay? Change your mind. What do I do to sine so that it pops on top of cosine? Plus pi over 2. They are the exact same graph, just shifted from each other. And we are going to talk more about transformations because the rest of this class is all understanding transformations. Is that what we just did, or did we do the opposite? Sine, yeah, plus pi over 2. Cool. Okay. Do you remember Unit 5? Well, we talked about how you can transform a function with constants in different locations. I got an A, a B, a C, and a D. Tell your neighbors what does what. What does the vertical dilation? What does the vertical shift? What does the horizontal dilation? What does the horizontal shift? And what is the thing you have to worry about that's like different than what we think? Go. Everybody, remind yourself. Go. Good. From Unit 5, we understood that vertical dilations were the A values, where we take our Y's and we multiply it by A. Remember when we did this in Unit 5? We did points, we did everything. Thomas, not a good thing, bud. You're locked in? All right, good. Cool. Whereas D was the vertical shifts, where we took our Y's and we added the value D. This was like direct in terms of what we expect it to do, a direct relationship. But horizontal dilations, B made a horizontal dilation. But what we would do is we would take our X's and we'd flip it. We'd divide by B, or we'd multiply by the reciprocal. C, if it's minus C, you would do the opposite. You'd add the C's to your X's. This was an inverse relationship. We learned about inverses in that unit, and turns out these compositions, to kind of understand what they do to graphs, you understand inverses. Dividing instead of multiplying, adding instead of subtracting. Okay? Okay. Okay. Y equals A. I don't care if it's sine or cosine of b x minus c plus d. We talk about amplitude, midline, phase shift, and period with these repeating functions. They're new words. You told me A is a vertical dilation for a function. What would A affect on the graph of sine or cosine? Tell your neighbors. Amplitude, period, phase shift, midline. You take your y's and you multiply them. Well, if you have a y of 0, multiply it by something, nothing happened. You have a y of 1, multiplied by 2, you're going to go higher. You're going to go lower. Let's see. I'm going to take sine x. I'm going to multiply it by 2. Boom. It goes higher. It goes lower. Makes sense. Okay. So we understand that this A, which is a vertical dilation, affects my amplitude. Let's stay with the y's. We know that D is a vertical shift. What will it affect on the graph of sine or cosine? Is it the amplitude? Is it the period? Is it the phase shift? Is it the midline? Tell your neighbors, what is that going to be? If you say midline, you are correct. It will add something to every single graph, every single y value. So I've adjusted my amplitude. If I add 3, look at what happens. I now have y equals 3 as my, I now have y equals 3 as my new midline. Right there. We've shifted everything up. We have a new middle. We can apply our amplitude. What's the maximum value of this graph? 2 sine x plus 3. What's the minimum value of this graph? 2 sine x plus 3. Tell your neighbors. Yo, if you have a midline of y equals 3, you have an amplitude of 2, what's the maximum value? 5. What's the minimum value? 1. It makes sense. It's easy. Cool? Cool. So we're just going to be transforming. The rest of this class, guys, is like graphing variations of sine and cosine. Okay? Cool. C. Horizontal shift. What's that going to change? Yeah, it's the starting point, the phase shift. The phase shift is the starting point. We're going to be good where we start. And then what does B do? The horizontal dilation, the most important thing for trig functions is this period. Yo, this one I'm going to start. This is the one that most people have the most problems with. Let's see. I'm going to blow through this. I'm pretty much going to do my own examples in a second. Like, I wouldn't do this one. Go to this period. Most of the other stuff you guys will figure out. I'm showing you how I'm going to do it, okay? Go to this period. Okay. I am going to put a 2 in front of this x. If I put a 2 in front of this x, what will happen to the graph? Tell your neighbors. You should know this from your work with horizontal dilation. If I put a 2, what happens? It's not going to make it taller. If I put a 2 right there, this is going to be a horizontal dilation by a factor of a half. I will take my x's and multiply them by a half. I'll take this x, move it over times a half. I'll take this x, move it over times a half. We will make things go faster. What's the period of this graph? If I put a 2 right here, what's the period? Yes, if you're taking a period of 2 pi normally and you multiply that by a half, you now have a period of pi. If you look at this graph, it goes up, down, back here. This is where we start repeating itself, pi 3. Okay, what if I put a 1/3 in front of this x? I'm going to put a 1/3 in front of this x. Tell me what happens to the graph if I put a 1/3 in front of this x. Tell me what the period is going to be. If I put a 1/3, it takes all my x's and multiplies them by 3. You take all of your x's, multiply them by 3, means you will take your period, which is 2 pi, multiply it by 6. Your period is going to be 6 pi. If I start at 0, I will repeat myself, bam, right there at 6 pi. Okay, I'm going to put a pi over 6 here. What happens? I'm putting a pi over 6 right there in front of x. What happens if I put a pi over 6? I'm going to put a pi over 6 next to that x. I'm going to put a pi over 6. Next x is going to be 2 sine pi over 6x plus 3. What is the period? Nailed it. A lot of people get to this point and they were doing good, and then it got harder. They couldn't figure it out. Some of you got it. Great. You're in a good spot. What you should be thinking is that you should be a horizontal dilating by a factor of 1 over pi over 6, or by multiplying by 6 over pi. Taking your x's, multiply them by 6 over pi. Take your period of 2 pi, multiply it by 6 over pi. Gives us 12. If you set a period of 12, you nailed it. Now I'm going to help you out if you couldn't really put that together, because horizontal dilations are tricky. What you did is you took 2 pi and you multiplied it by the reciprocal of b. You took 2 pi and you divided it by b. We start at 0. We repeat ourselves at 12. So, everybody, your period, you will take your standard period of sine and cosine, dilated by the factor of b, means divide it by b. This dividing by b means you're doing a horizontal dilation. Okay, what's the period of this? It is. What's the period of this? Everybody figure out what's the period of this. If I have a 4x, the period's usually 2 pi, but I have a 4, which means I'm horizontally dilating by a factor of 1/4, 2 pi over b, pi over 2 is correct. You take your normal period, when you go around the circle and you start repeating, you do the dilation, divide by b. What is the period of g? Take your normal period, dilate it by a factor of 1 over pi, 2 pi over b. You get your period of 2. Cool? Yeah. We'll talk about what that means next, okay? A is amplitude. B affects the period. C affects the phase shift. D affects the midline or the vertical shift. Go to the back. You're doing a horizontal dilation, Schreier. Sure, but the period of sine x is 2 pi. So like at 2 pi, I start over. Do a dilation off of 2 pi because that's where your normal graph repeats. You're thinking about x is 2 pi. X equals 2 pi is an x coordinate where your graph repeats of sine. You dilate that to get your new period. By doing the dilation. The dilation that you know how to do. You do. Okay? Okay. Guys. Understanding all that, this is how we're going to graph. Graphing trig functions is a little bit trickier because of it going up and down and the fact that we repeat. So we're actually going to use a special technique that makes it a lot easier than normal. It's called a box technique. Everybody draw like a rectangle, please. And we are going to start out with our friend y equals sine x. And do a box underneath it. Y equals cosine. We are going to graph one period of sine and one period of cosine, and that's it. Okay? Now, what does this look like? This is going to be a pretend y-axis, and this is going to be a pretend x-axis. So this will be x equals 0. We know that one period of sine goes to 2 pi. And then my steps, which are my period divided by 4. In this case, my steps are pi over 2. So this is the whole idea of like go around a quarter of the circle at a time. Pi over 2, pi, 3 pi over 2. Woods, pay attention. We have our midline. Our midline for y equals sine and y equals cosine is y equals 0. We have our amplitude. Up 1, down 1 to get y equals 1 and y equals negative 1. Copy that down for cosine. Ready, set, go. Everything is the same. Okay. Okay. What does the graph of sine and cosine look like? This is your job right now. This is your job right now. Where's our first point go? At x equals 0, do we have -1, 0, or 1? Here, at x equals 0 for cosine, do we have -1, 0, or 1? Plot your first point, please, for both of them. Or think to yourself, when x is 0, the sine of 0 is this, I know this. When x is 0, the cosine of 0 is this, I know this. What is the sine of 0? What is the cosine of 0? The sine of 0 is 0. The cosine of 0 is 1. Cool. What happens next Do I go up or down at pi over 2? What is the sign of pi over 2? This is the one question. What's the sign of pi over 2? Is it positive 1 or is it negative 1? Okay, so we can kind of figure out from there, understanding repetition, maxes and mins, positive 1, 0, negative 1, 0. This is the graph of one period of time. Cool. We're keeping this in our brains. We know this. We can recreate this like that. We know it repeats to the right, to the left. We could do that if we wanted to. We're good. We know cosine. It's really the same idea. The only difference is it starts at 1, goes to 0, goes to negative 1, goes to 0, goes back to 1. Boom, we start repeating. Okay. I'm going to do 2 graphing examples, and that's pretty much going to cover our notes. And then we'll go to the homework and we'll try to do one where I'm going to give you the graph, you're going to give me the equation. Here is one graphing example. I want you to graph y equals 3 sine pi x plus 4. This is the question. This is the first couple pages of your homework. Graph this. Now, what you are used to doing, guys, is like starting with an XY axis and like graphing. What we're going to do is shift the box. What you can't see, but what's there is that there is an x-axis here. There's a y-axis here. I am not going to start with an x-axis, y-axis. I'm going to start with a box. I'm going to shift the x's and the y's on my box, and then I'll find out where the x-axis and y-axis goes from there. I'll show you what that looks like, and it's new and it's different, but it's so much easier than any other way. Watch. Give me a box. You guys got me a box? Cool. Let's start with our y's. Which of these numbers are affecting the y's and how are they affecting them? You should be able to label your midline, your max value, and your min value. Go, tell your neighbors, where is your midline, max, and min based on the numbers that you see there? Very good. You understand that this 4 is a vertical shift. We know that from Unit 5. We understand that affects my midline. So y equals 4 is now my new midline, not y equals 0. I have shifted things up even though like I haven't really. We know that 3, being my vertical dilation, is going to affect the amplitude. Okay, I'm going up 3, down 3, giving me to a 7 and a 1. Cool. What affects the x's? Well, is there a phase shift? Tell your neighbors, is there a phase shift? Is there a horizontal shift? No phase shift. So x equals 0 will stay. No, it's not. What does pi do? Tell your neighbors. Okay. Pi is going to affect the period. What is the period? Well, the period starts as 2 pi. You take that 2 pi, we horizontally dilate it by a factor of 1 over pi, or you can always do 2 pi over b. It's like it's just what you do. Getting that the period is 2. Okay. Now, if I start at 0, I add 2 to get to my end. But watch, I'm going to go one step at a time. What are my steps? Taking your period and dividing it into 4 equal parts. Your period is 2. Step that out by dividing by 4, and we will step 1/2 at a time. 1/2, 1, 1.5, 2. You guys comfortable with what I just did? I start at 0. I have a period of 2. I step that out by dividing it by 4. 2 divided by 4, half, a half, a half, a half. I get from 0 to 2. Boom. Okay, now, what does my graph look like? Well, it's the same as what the sine x graph looks like. Only, what does it look? It's like, it looks like the same thing, Mr. Master. You're giving me the same graph. I'm not giving you your same graph, because the x-axis, yes, it's still here. I mean, the y-axis is still here, but the x-axis is down here. This is y equals 1. This is y equals 0. So it's like you shift the locations on the outside, and then you can kind of figure out where the y and the x-axis go. It's so much easier to do this. It's a new type of graphing technique that you wouldn't have done before, but it works great for these ideas. Watch. 3 sine pi x plus 4. Okay, zoom in a couple steps. Zoom out a little bit. Give me some points on your graph.
1.
No, give me x, y.
1, 4.
1, 4?
0, 4. 1.57.
0.57. You guys have 0.57 on your graph? Do you guys have 1.51? Do you have 0.4? You have your graph in this box. You just don't realize it. 0.4, 1/2, 7, 1/4, 3/2, 1. Okay, now let's do another one. Ready? Y equals cosine 2 x minus pi over 4. We start with our box. I have no amplitude adjustment. I have no midline adjustment. Y equals 0. Y equals 1. Y equals -1. But I have a phase shift. This is the most important one, guys. Pay attention to this one. I'm going to shift to the right pi over 4. So this is my new starting point at pi over 4. What is my period? No, what's my period? My period is taking 2 pi and horizontally dilating it by a factor of 1/2. My period is pi. What, therefore, must be my step? Pi over 4. We will add pi over 4s 4 times to realize if you start at pi over 4 and your period is pi, you have to end at 5 pi over 4, and you have pi over 2, 3 pi over 4, 4 pi over 4 along the way, which you can simplify. The graph of cosine starts at a max, hits a min, goes back to a max. You've just adjusted. Make sure you do your homework. Good intro, but it was a lot. Thanks.
This 2 pi, you multiply it by 0.2,
So you think about twiring this point right here. That's the end of the regular graph. We dilate it the way we should dilate it, okay? Here I have 2. No, I don't multiply by 2 because what happens with horizontal dilation? You divide by 2. So I take that 0.2 pi, I divide it by 2, but I also shift it over pi over 4. Okay? So all of those points there, you divide by 2 and you add pi over 4. Yeah. Right. That's all you do. You just shift the numbers.